Yeah, I just want to take you through the sedimentary deposition environment as I've learned so far. Yeah, we have three type of deposition environment. We have the continental, the shallow marine, and the deep marine environment. Yeah, from the continental environment, that is we are on land. So what we have there is just we have the Aeolian, the lake, some rivers. Then we have delta. So we might have some alluvial fans. So from the definition alluvial fan, which is continental, so we have some let's say we have some sediment passing through, coming through some rivers within the high areas. Then where we have high velocity. So as soon as the river escape those areas with high, very narrow area with very high velocity and get to area with lower velocity and more spaces, more lower land, they became to expand and the materials loses their energy, then they became deposited in this particular and form like an alluvial fan. So meaning that the proximal material is going to be a little bit of higher energy than the stem material. So talking about lake, this might be a giant body of ice that has been here for long and maybe sediment are deposited and form a big, very might be as deep as kilometers, form a deep hole that can contain water. So with time, this might be full of water and it might be open, it might be closed. So we have some Helian. This is work of wind. So sediments which are deposited either by fluvia or any other means of deposition can be reworked, carried away by wind, and this can be a deposition environment on its own because it could be deposited in terms of you can see some unidirectional current bed form like wind ripple and some dims in your Aeolian deposits. Mostly we have clean mature sand because most times it travels a lot and mostly of clear material free, so which is very good reservoir for in terms of oil and gas. So so we have some fluvia deposits, which are fluvia is just like deposits sediments which are deposited by river. We have different types of river. We have meandering river based on the sinuosity. We have the straight river that just doesn't really meander in this way. So in terms of river, we have different fascias for alluvial deposits. So in terms of the meandering river, we can have different fascias. You can see the point bow. So this can be like can have some lacular accretion of sediment. So in this case, mostly we have heterogeneity in majorly in the channel towag closer to the point bar deposit as the river because we have high energy here. So as the river it drops some sediment and have moved forward. And this is the old channel. This is an oxbow lake, meaning that the river was passing in this way, but it goes further, disconnect, and at the end of the day, maybe disconnect back and form an oxbow lake. So this is a delta. So in terms of reservoir, the channel is very good, and the sequence is just finding up chord sequence. We're coming to that. The sequence for each deposit. So we have some delta here. So we are moving gradually to the shallow marine environment. So we have some delta here, which means we have high energy sediment coming into the marine, and the energy is more higher. So in a way that they can protrude into the shallow marine environment. We have some cases where the energy in the water is quite in the marine is quite higher. So In this case, we have energy from the river coming much more higher than the marine, the energy of water here. So we have this, it's a fluvial dominated delta. We have some delta, you can see the rivers are bifurcated, and we have some mouth bar and some channels within the delta. So here we have a delta that has been, you can see the shoreline is almost straight. So this is the delta. Just it might be like this earlier, but this can be this. The materials over here might be reworked by the wave, the wave, the water wave. So in the shallow marine environment, yeah, we can have the the tidal effect too, whereby the water energy is higher to the extent of protruding into the ground, bringing sediment from the ground back to the the land. So like we have transgressive shoreline. So we have, can see this strand is like a barrier sand, a barrier beach. So forming when the energy is coming and depositing some high energy, then we have just shallow areas. So we have something like a lagoon here because low energy material is going to be here, because the high energy are just forming barrier beach around here. So in the shallow marine environment, we have the shore face, the upper shore face, the middle, the lower shore face. So you can see we have some carbonate platform around here. So this is talking about the carbonates forming up around here in the shallow marine, because we know carbonates actually form in shallow marine environment where we have organisms that are capable of doing this reaction, producing this in this environment, because they are typically they typically live in the area that is tropical. So though this deals with the shoreline, the transgression and regression of the shoreline, this actually deal with this. So if you have high water level, they might not be able to catch up. So we may have something like a drawn platform or so. So then we can have a reef catching up and keeping up with the water level. So basically, the forming of this deals with the water level, the regression and transgression of the shoreline. So this is very good for reservoir. So in terms of delta, the distal part is quite not good for reservoirs. We have some low energy material, while the proximal part is quite good because we have some high energy material which is being deposited. So as I've said earlier, it can be hypopycna or hyperpycna flow. So within the shallow marine environment, as I've said, we have the upper surface, which is basically of sand, beach sand, and sand. The lower shore, the middle surface, and the lower surface is just about closer to the having some marine materials beneath. So basically, data in terms of a fascia is just it deals with progradation, like the Kwasni upward sequence. So we have some coastal plains, some subcast, so it can be like a super tidal. So in this area, we can have tidal effects, shoreline moving upward and downward. So we might have some peritidal area here where we might have some carbonates around this area also. When the shoreline transgress and regress back, the the materials there might be super saturated, which are super saturated with maybe some calcium. So at the end of the day, we can have some precipitation of a carbonate, and even to some extent, we can have some precipitation of some evaporite like salt, depending on what the the water contain and all the or the sediment contain. And in this area too, we can have some carbonate in the lake maybe, and we can have some salt precipitation of evaporite in a lake around. So which is quite, evaporite can be a good seal because they have good mechanical seal capacity, and the capillary, in terms of capillary ability, they have very, very good constraint to breaking of seal in terms of capillary force. So yeah, let's talk about the slope, the shelf slope, where we have some canyon. So in this case, this canyon is just like a a big erosion that is a big, as a sort of a big breakage as a result of erosion in the slope, where we might have some channels there. You can see this might be some, there might be some channels which can be a good reservoir. So as this material moves downward, it forms something like submarine fan, where we have low energy material in the distal part, high energy material towards the proximal part, depending on where you are. So this can be in the deeper marine environment, or have some organism around, many organism around. So the organism can be capable of maybe forming with time. They can be organic. They can be they can die down the make the sediment organically rich, and with barrier and also other conditions. This can be a good source rock in the distal part of the of the submarine fan. So this can be a good reservoir. This can be a good source rock. So in terms of the slope, you have some debris, debris as a result of maybe slope. We can have it as a result of slope failure or so, and some soft sediment deformation around this area. The debris is just talking about a laminar flow. It means when these materials fall, instead of them going separately, they are stick together. They are viscous. They are stick together. They are less viscous, so they move slowly, and they are deposited as they are moved. They are not mixed together. So we can have some turbidite, which is in turns, turbidite can be zoned. So the sandier part, even in the channel, we can have some turbidites, where we can have, as we can have channel here. You can see these are overbank. You can have a crevasse splay, maybe when the water is coming, and just break some levee. If you have some levee build up around here, it can break the levee and start coming through this and form some crevasse splay in the overbank. So we have this overbank. So we can have that in the deep marine also. So the overbank, they are like the levee is not, we don't have the sand which are as fine, which are as coarse as this channel, but is a little bit more finer than the channel, the sand in the channel, because of the energy. Because normally when we have a channel moving, so the low energy material are going to be up, the high energy material might be down. So the water that is going to spill the materials with the low energy. So forming, making us have a material with low energy around the overbank, and even the crevasse play. So in the overbank, you can have basically some organic materials too, because we have some trees, and so some dead trees and every other materials that are here in the overbank. The flood, it can be a floodplain. So this is just the turbidite is just talking about turbidity flow. Like, where we have some uh, materials, some sediments moving and are seriously mixed together, so they are deposited based on the energy, the water energy. So we have series of, we have sand area, and basically based on where the hive it is in the channel, we can have some unidirectional current bed forms, and the zones, based on the zones where we have sand, especially in the channel or the proximal part of the turbidites, you can have good reservoir, and at the same time you can have a good source rock, depending on where it falls. It can fall where we have, it can be formed at the distal part, where we have some shale, maybe probably rich in organic, it's the evidence of some harmonite, so it can probably a good source rock. Yeah, I think this is just how I can put them together for now. So I'll be taking you through some fasces, but this might not be detailed. So this is just what I've learned from the Aberdeen University. So which I think is not going to be detailed enough here, as you might need to come and learn that yourself. Thank you.